Hello, let's go ahead and take a look at this problem. First of all, when we start looking at what they're asking, they want us to find the center and the radius of the circle. So in order to find the center and the radius, the best thing to do is to get this into standard form. The standard form of a circle looks like x minus h quantity squared plus y minus k quantity squared equals r squared. Now if this is the standard form for a circle, the center of the circle is at hk. And if you notice, that's opposite. So here I have x minus h, and my center is at the positive h value. Same with k. And then over here, my radius is just equal to the square root of the right-hand side. So we need to get it into this form. And the way that we're going to be able to get it into this form is by completing the square. Now when you complete the square, basically we need to group all the x's together, all the y's together, and then we'll move everything else to the right-hand side. So the x's are already grouped together, and then I'm going to leave a space here. And then I will include my y values and leave a space here as well. Got the plus sign over here. And then on the right hand side I have my constant, and I actually think I'll write that a little different. On the right hand side I have my constant, which was given to me as 1. And then because I have a blank on the left that I added, I also have to add the same amount on the right. So this blank associates here, this one associates here. So what I do to complete the square is I take half of my linear term. So half of 2 is a positive 1, and I square this value. Well, if you add that to one side, I also have to add it to the other side. Now also, on the left-hand side, I need to work with completing the square here. Well, half of a negative 8 is a negative 4, and I have to square that value as well. Now please note I am squaring the negative and the 4, not just the 4. And of course I have to keep that balance, so I need to do the same thing to the other side as well. So it looks like what we have here then is x squared plus 2x plus 1. Okay, then next I have plus y squared minus 8y plus a negative 4 times a negative 4 is a positive 16. And this equals on the right hand side 1 squared is 1, and then a negative 4 times negative 4 is a positive 16. So my next step is to look at this in terms of grouping. So if I had to factor this, this would look like x plus 1 times x plus 1. And guess where the plus 1 came from? It matches the same value that I have up here. Now next I'm looking at y squared minus 8y plus 16. This factors into y minus 4, y minus 4. And again, guess where that came from? That came from right here when I took half of the negative 8 and I have the negative 4. That negative 4 is right down here, it reappears. And then on the left hand side I have 16 plus 1 is 18. So we're almost there. X plus 1 times x plus 1 can be rewritten as x plus 1 quantity squared. Y minus 4 can be rewritten as y minus 4 quantity squared. And then on the right hand side I have 18. So if I'm looking for the center of my circle, and again what I'm doing here is I'm following the center from the HK, so it's going to be the opposite. So my x value will be the opposite of a positive 1 from right here, will be a negative 1. And then for my y value, it'll be the opposite of a negative 4 is a positive 4. Now the radius is the square root of the right hand side. Now one other thing with the radius, you can break that up into root 9, root 2, factors of 18 that are perfect squares. The square root of 9 is 3, so I'm left with 3 root 2. So I guess I can't remember. I guess they wanted the center, and I probably in the next part they'll ask for the radius after you get that entered. But it looks like the center is negative 1, 4, and the radius is 3 root 2. I hope this helps. Okay, let's go ahead and take a look at the graph of this first. So to get started, it looks like we need to pay close attention to what's going on with this graph. Now, first of all, it says, what is the vertex? Well, the vertex of a parabola is its either lowest point or its highest point, depending on whether it's opening up or down. So this parabola that we're looking at, clearly the lowest point is right here, right about there. So if we were to try and look at this graph, it looks like it would be the ordered pair, if we were going over from the origin, 1, 2, 3 units in the x direction, and then in the y direction it looks like we go down 3 units. So I think the vertex here would be 3, -3, if my old eyes are looking at that graph correctly. I should have brought in a bigger version. Now that's my vertex. Now axis of symmetry, I'm going to blow this up a little bit, is basically this line right here that goes through that vertex. Now this is a vertical line, so it's an x equal value, and it's going to equal whatever my x value is. So in this case it's x equal 3. Now the directions here to say type an equation, so we need to make sure we include the x equal 3. Now range is my y values. So for my y values, it looks like to me my y values go from this point all the way up toward positive infinity. Well, this point for my y values is equal to -3. Now this has to put this in an interval notation. So for interval notation, this would go from -3 to infinity. Now I never actually reach infinity because as soon as I think I get there, it goes one more step past. So I need to make sure I have a parenthesis here. You don't necessarily need 4 sets like these, okay? But you definitely need some parentheses there. So parenthesis. Now -3 I actually reach, and so it's a bracket because -3 is actually on this graph, and I actually do reach that. So my range would go from -3 to infinity, and this says interval notation, and this is what they mean by interval notation. Now the function is increasing on the interval. Let's go ahead and blow this up again down here. It's increasing on this interval, let's say from here, trying to get a bigger tip here, to here, so it's increasing. Okay, so this point, if we're thinking about our x values again, is -3. So it increases from -3 to positive infinity in the x direction. Now the decreasing part of this, I'm decreasing over here in the blue, so that's going from -infinity up to -3. Now at the very point of -3, this graph is neither increasing nor decreasing. It's kind of a flat line here at this point, so that's why I'm not bracketing the -3 here. So I hope this helps to clarify some of the parabola work. If you have questions, please let me know. Okay, to get started on this problem, first of all, let's remember that we are working with a circle, so that'll help us remember that we need to work with the standard form of a circle. And when we're working with the standard form of the circle, let's go ahead and write it down just so we remember it. It's x minus h quantity squared plus y minus k quantity squared equals r squared. And I think the question about why is the radius the square root of whatever number you had in the email comes from the fact on the right hand side to find the radius you have to take the square root of the right hand side. Well, let's go ahead and build up to where we're looking at the square root. So we need to find the standard equation of a circle that passes through a given point, and they give us the center. So that was kind of a nice thing for them to give us. Now when we're filling this out, what ends up happening is the value of 3 is my x value. It just plugs right into the general form. Now don't be concerned because there's a minus sign here, because we always have a minus sign from the formula. So if this had been a -4, this would have been x minus a -4 or x plus 4. So there's a couple things going on there. Also we see a 6 here for my y value, so I'd put a 6 in here. So it looks like we have everything we need except for this value of r squared. Well, let's go ahead and figure out what's going on here. If we were to plot some points here, 1, 2, 3 over on my x, and on my y, I have to extend that out a little bit. This is the center of my circle. Then it says it's also passing through the point 1, -1. So here's the point 1, -1. So again, this is my circle. This is the center. And so this is basically the radius of my circle. So I need to find the distance between this point, 3, 6, not 6, 3, 3, 6, and this point of 1, negative 1. Now there's a couple different ways that we can do this. One thing that we could do is we could drop an altitude down here and realize, oh, I have a nice right triangle. Now the distance from this value of x equal 1 right here to 3 we know is a distance of 2. Now this height right here is 6 above the x-axis and drops 1 below, so this is a length of 7. And then I can use Pythagoras Theorem. So Pythagoras Theorem says if I take each of the legs, square them, and then add them together, so leg squared plus leg squared would equal my hypotenuse, which is the side opposite my right angle squared. So here I have 49 plus 4 equal r squared. 49 plus 4 is 53, is r squared. So I have r squared equals 53. However, r is going to be the square root of that, because I'd want to take the square root of both sides, and I'd get r equals the square root of 53. So that's my radius. Now back for my standard form, what I would do is I would replace this r squared value with not just good old r squared, but we would replace this with 53. So again, r squared is equal to 53. The reason we take the square root of it is we want to know what r is, not what r squared is. So this would be the standard form of the equation. The center they gave us was 3, 6, and then the radius, which they asked us to find in lieu of putting into standard form of the equation, is square root of 53. I hope this helps. It's kind of a tricky little question, and it's an easy mistake to make, so watch out for it on the test.